The convergence of artificial intelligence, AI, and robotics has ushered in a new era of technological innovation, culminating in the development of human-like robots. These robots, often referred to as humanoids, are designed to mimic human appearance and behavior. With the advent of 3D printing technology, the creation of these robots has been revolutionized, allowing for more realistic, functional, and customizable designs. This video explores the future of AI and robotics, focusing on the development, potential, and implications of 3D printed human-like robots. Before we move forward, please take a second to like and subscribe to our channel. The evolution of humanoid robots. Humanoid robots have evolved significantly in recent years, advancing from simple automatons to highly sophisticated machines. Initially, robots showcased abilities like basic walking and performing limited tasks. Today, advancements in AI have dramatically enhanced the functionality of humanoid robots, enabling them to understand and respond to human emotions, perform complex tasks, and learn from their environments. Modern humanoid robots can now engage in meaningful conversations, provide personalized assistance, and adapt to new situations. The incorporation of 3D printing technology has further revolutionized their development, allowing for the creation of highly detailed and lifelike designs, including custom joints, facial features, and skin textures. This technology not only enhances the aesthetic appeal of humanoid robots, but also improves their functional capabilities, making them more efficient and adaptable in various applications. The role of 3D printing in robotics. 3D printing, also known as additive manufacturing, has had a profound impact on various industries, including robotics. This technology allows for the creation of complex structures with high precision and efficiency. In the context of humanoid robots, 3D printing offers several advantages. Customization and precision are paramount, as 3D printing enables the creation of bespoke parts tailored to specific requirements, enhancing both the functionality and aesthetic appeal of humanoid robots. Custom joints, facial features, and even skin textures can be designed and produced with high accuracy, resulting in robots that closely resemble humans. The rapid prototyping capability of 3D printing significantly expedites the iterative process of design, testing, and modification. Prototypes can be quickly produced and tested, allowing for rapid iterations and improvements, which accelerates the development cycle and reduces the time to market. Additionally, 3D printing allows for the use of various materials, including flexible, lightweight, and durable options. This material diversity enhances the realism and utility of humanoid robots, enabling the creation of components that closely mimic human tissues, muscles, and bones. Advancements in AI and their impact on humanoid robots. Artificial intelligence is the driving force behind the cognitive and functional capabilities of humanoid robots. Recent advancements in AI, particularly in machine learning and neural networks, have significantly enhanced these robots' abilities. Natural language processing, NLP algorithms, enable humanoid robots to understand and respond to human language with greater accuracy, facilitating more natural interactions and allowing robots to engage in meaningful conversations, provide information, and offer assistance. Enhanced visual processing capabilities through computer vision allow robots to recognize and interpret visual data, enabling them to navigate environments, identify objects, and recognize people. These algorithms have advanced to the point where robots can understand complex scenes and perform tasks such as sorting and assembling objects. Additionally, AI algorithms now enable the interpretation of human emotions through facial expressions, body language, and tone of voice, allowing robots to respond empathetically and appropriately. This enhancement in emotional intelligence significantly improves their ability to interact with humans in a socially intelligent manner. For instance, robots like Pepper by SoftBank Robotics are designed to read emotions and adapt their responses accordingly, making them suitable for roles in customer service and healthcare. Applications of 3D printed human-like robots. The potential applications of 3D printed human-like robots are vast and varied, spanning multiple sectors. Healthcare. Advancements in healthcare are incorporating humanoid robotics to assist in patient care, surgery, and emotional support. Robotic surgical systems, exemplified by cutting-edge technology such as the Da Vinci surgical system, are transforming minimally invasive procedures, ensuring precise and controlled operations. Additionally, humanoid robots are aiding in patient care by monitoring vital signs, assisting with mobility, and managing medications. These robots, equipped with sophisticated AI, provide real-time health monitoring and support, enhancing patient well-being. Education. Robots can serve as teaching aids, offering personalized learning experiences and assisting in special education. They can help students with disabilities by providing tailored support and facilitating inclusive education. Customer service. Humanoid robots have become integral to enhancing customer experiences in retail and hospitality. Advanced robots like Pepper and newer models have been deployed in stores, airports, and hotels to greet customers, answer queries, and offer personalized recommendations. These robots use sophisticated AI to provide information, assistance, and entertainment, improving customer satisfaction significantly. They can handle routine inquiries and tasks, freeing up human staff to focus on more complex and nuanced customer service interactions. Ethical and societal implications. The rapid advancement of humanoid robotics raises profound ethical and societal implications. Questions arise regarding the ethical treatment of robots, considering their increasing capabilities and semblance to humans. Concerns about job displacement and economic inequality surface as robots replace traditional roles in various industries. Moreover, the potential for misuse of AI-driven robots poses risks to privacy and security. Future prospects and challenges. The future prospects of 3D printed human-like robots are promising, with ongoing research and development poised to overcome current limitations and unlock new possibilities. Advancements in materials, science, artificial intelligence, and robotics hold the potential to create more lifelike and functional robots that can perform a wider range of tasks. However, challenges such as refining printing techniques for intricate details, ensuring durability and reliability of printed parts, and addressing ethical concerns surrounding their use remain. Overcoming these hurdles will be essential to fully realize the potential of 3D printed humanoid robots and integrate them effectively into various aspects of society. The convergence of AI, robotics, and 3D printing technology has brought us to the brink of a new era in the development of human-like robots. We can harness the full potential of 3D printed human-like robots, creating a future where they coexist harmoniously with humans and contribute positively to society. The journey ahead is filled with exciting possibilities, and with careful consideration and thoughtful planning, we can ensure that the future of AI and robotics benefits all of humanity. Thanks for watching, and don't forget to like and subscribe.